Hello everyone, and welcome back to the Fluctus channel. In order to improve its technological and combat capabilities, the U.S. Air Force implements development programs that promote the use of new devices and aircraft. One of these programs is the Collaborative Combat Aircraft Initiative to develop and create new unmanned combat air vehicles. The primary goal of the CCA program is to deploy at least 1,000 unmanned aircraft, pairing them with advanced manned fighters like the F-35 and NGAD systems. There are several defense contractors involved in the development of the program, including Anduril and General Atomics Aeronautical Systems. For example, Anduril's Fury AAV was designed from modular systems that work with commercially available hardware to avoid over-engineering. On the other hand, General Atomics' XQ-67A prototype, which has already conducted its maiden flight, will serve as a force multiplier by performing various tasks, including surveillance, target acquisition, electronic warfare, and even combat missions. However, these developments are not exclusive to these two companies, as many compete to develop similar projects. Such is the case of the Scaled Composite Sierra Model 401, an experimental aircraft designed to demonstrate cost-effective manufacturing methods while serving as a platform for various research and development missions. These low costs are also due to the aircraft's simple design, but with great potential. By having a long endurance and operating at altitudes of up to 30,000 feet, it's ideal for experiments in high-speed winds, test sensors, and other aerospace systems. Still, these developments, especially those related to unmanned aircraft, must be governed by FAA regulations. To develop these regulations, efforts are being made by research centers to determine how these devices should be operated. Such as the William J. Hughes Technical Center, where the FAA and NASA test how advanced air mobility vehicles can operate in high-density airspace. From similar tests, manufacturing companies such as Scaled Composites obtain data that allows them to improve models and develop new designs. This was the case with the Model 401, which laid the groundwork for its successor, the Model 437 Vanguard. Its improvements focused on increasing the payload capacity and adding stealth features while also placing emphasis on digital engineering. Another key aspect that was improved from the 401 is that the Model 437 was developed to be operated either as a manned or unmanned aircraft alongside fighter planes. Innovations implemented in aircraft such as the Model 437, especially the integration of digital systems, have been shown to be a trend in the future, as demonstrated in other concepts such as the X-62A Vista. This plane, which is a highly modified version of the F-16D Block 30, has shown groundbreaking advancements in autonomous flight and AI-driven maneuvers. During a test flight, the aircraft executed a series of tactical maneuvers using AI agents that responded to simulated threats in real time. These technologies show the potential of AI-based decision-making in combat, which has paved the way for several civil projects, especially for interesting military initiatives. This is demonstrated by the U.S. Air Force project called the Skyborg Vanguard program, which aims to develop an affordable fleet of unmanned combat aerial vehicles equipped with AI technology. The idea is to integrate autonomous drones with fighter jets like the F-35 or F-15EX to offer surveillance or combat support. To test these technologies and obtain better feedback data, the Air Force Research Laboratory implemented the USAF Autonomous Aircraft Experimentation Program. During these experimental sessions, the Air Force tries to understand the scope and scale of what is necessary to implement AI in aviation. An example is the Autonomous Attritable Aircraft Experiment, centered on exploring the potential of low-cost autonomous UAVs. Often referred to as attritable aircraft, which can be expendable, but with the capability of executing complex missions in support of manned aircraft. During this program, many tests for different autonomous systems have been supported by machine learning operations and collaboration between industry and government entities, such as DARPA. Of these autonomous platforms, there is the Kratos XQ-58 Valkyrie, built to break the high-cost trend of modern combat aircraft, being priced at a fraction of the cost of crewed fighters like the F-35. Making it an economically viable option for missions that might put aircraft at high risk of destruction. It has a low radar cross-section that makes it difficult to detect, which is essential for stealth missions. Thanks to its high endurance, it can fly long-range missions, which is useful for deep strike operations and combat air patrol. And by having an internal bomb bay and wing stations, it can carry a mix of lethal payloads, including precision-guided munitions and electronic warfare packages. Those features of the Valkyrie were further tested during the Penetrating Affordable Autonomous Collaborative Killer Portfolio Program, assessing the capabilities of the aircraft to get into heavily defended airspace. Typically, these spaces are areas with anti-access and aerial denial systems, such as surface-to-air missile systems. For this reason, the aircraft's stealth systems are monitored, and it's determined whether or not its design can evade the most commonly used detection devices. Just as initiatives such as AAAX or the Autonomous Aircraft Experimentation Program work, There are other projects that seek to improve the effectiveness of the Air Force, such as the Agile Combat Deployment concept, designed to enhance the force's ability to project combat power and maintain operational flexibility with increasing global threats. The central idea of ACE is to achieve the distribution and dispersion of units and capabilities across multiple and varied sites. This strategy promotes the integration of different military forces, including air, ground, and naval forces. It encourages them to work in joint operations to take advantage of the capabilities of each of these sections. ACE seeks to challenge current logistics systems and transportation nodes. Its purpose is to transform supply and distribution systems from a fully connected pull system optimized for efficient operations to a push system that maximizes distributed mission effectiveness. These improvements come from implementing predictive models that help anticipate the logistical needs of teams, whether it be more fuel, parts, or vehicle maintenance. This was proven during the Agile Flag 24 exercise using the X-Wing autonomous logistics aircraft. During this testing event, the X-Wing Cessna 208B showed its autonomous capabilities, which included the ability to taxi, take off, fly to a destination, and land without human intervention. This exercise involved several airmen loading equipment and cargo onto the aircraft to demonstrate that similar autonomous aircraft can be easily integrated into common logistics operations. After loading, the X-Wing initiated the autonomous flight demonstrations, during which several airmen watched the plane's operations from a ground control station. The exercise assigned X-Wing cargo missions based on real-time logistics needs. This included delivery of sensitive weather equipment and other critical cargo to various locations throughout the week-long event. The tests were not simply technical demonstrations, but allowed aviators to see how autonomous flight could directly support real-time logistical needs. The emergence of new technologies in recent decades, whether new manufacturing techniques, new materials, or advances in AI, has been fundamental to the development of innovative projects in the armed forces. These technologies have allowed the emergence of cheaper aircraft and the implementation of new autonomous systems, which provide better support to existing planes. It will not be surprising that we will see a greater influence on these technologies and the creation of exceptional aircraft in the future. That's the end of this video.